Hello everyone and welcome to another eCognition Deconstructed video. Today we're gonna have a really nice algorithm that I actually never used that often before, but after this video I promise you're gonna use it as well. I'm gonna use it as well. It's really cool. And it's called Find Domain Extrema. And this algorithm finds extreme values, minimum or maximum, that you define in the domain. Here's a definition that you'll find in the reference book. So what does it do? It allows to identify areas that fulfill a maximum or minimum condition within the defined domain according to an image object feature. So you can choose any feature that eCognition provides and use this in defined domain Extrema. Let's say in this example you want to find the longest image object. That's no problem with the Find Domain Extrema algorithm. So in this case, it would be that long one, right? You also could say, all right, I'm looking for the next slide, smallest. And looking for the smallest would be this image object down here. And one last example, find the brightest. It would be a different one. So we're using the brightness feature. And is there another one? The largest, all right. So the largest would be that one on top right corner based on the feature area of a single image object. Okay, let's have a look at a use case. Enough of theory. What do I have here? I have a DTM. And I did already a segmentation, and that looks like isolines. Is that the right term in English? I think so. And what I want to do now is simply find the highest image object of my image objects on this level. And I'm simply going to use this Find Domain Extrema algorithm. And here you see in the domain we're working on image object level 1. That's the stuff that you see on the left hand side. And the Extrema settings, so the algorithm parameters, are more interesting, so you can define an Extrema type, minimum or maximum, then the feature that you're looking at. In our case, we are looking at the mean DTM, so the elevation of the terrain, but you could use all the features provided here within eCognition. And another important setting is the accept equal Extrema. You can set it to yes or no. If it's set to yes and you have equal Extrema, both gonna be, or all of them gonna be classified. If you set it to no, only one will be classified. Let's execute this, and I do not see anything going on. So I'm gonna show you a trick how you could find a hidden classified image object. You can open the object table, and in this case I'm already displaying my maximum class and unclassified. So you can depict here what classes and what features you wanna have displayed in the image object table. And now I actually can click it and it will be highlighted. And it will also center it in the view. So if you're in another area and you click it here in the image object table, it will zoom to that selected image object. Okay, so the next one is Find Domain Extrema as well. And here we're simply gonna go for the minimum. So we have both the minimum, maximum, and we're gonna put it into that class minimum, this image object. So minimum is black, maximum is white. And now it also appears here in the image object table, and it's right at the top right border of my image. And that's how you can use this to get the highest and the lowest image object in your image object level. Let's delete our classes and have a look at other settings. So again, here we can check it in the edit process window or in the process property window on the right hand side. It's exactly the same. And we simply changed the feature from DTM to area. So in this case, we want to look for the largest image object. There we have it. So that's fairly large, and it actually looks like the largest one for me. Let's add this area feature here as well. So at the moment we only have in this table the mean DTM, but I'm gonna add the area, and you see it here in pixels. And the cool thing is here you can also sort it. So right away you see the largest image objects with this very high number of pixels, and it's classified as maximum after executing this find domain extrema process and algorithm. So next one is simply finding the minimum, so the smallest image object. Let's check that one, and now you see that's an effect of the setting except equal extrema. So we have quite a few that are only the size of one single pixel, and they were all classified as minimum. So that was a very generic example and use case that might not be very helpful for you, but you should get the idea how this find domain extrema algorithm works. Now in this next example, that might be more realistic or give you ideas how you can use it in your rule sets. So in this case we have an NDSM, so normalized digital surface model, which depicts the height of the features on the terrain, so the elevation of buildings and so on. And we also, well, I loaded the outlines of the buildings of this city into this project. And in pre-processing, I simply did a segmentation based on the thematic layer. And in this case, again, I'm gonna look for the highest building and the lowest building. I don't see them after execution, so let's again use this image object table. Click on maximum, I zoom in, so it centers it. So that's the minimum. Elevation of 0. That might be an error in the thematic layer, so you could improve that. And this is the highest one, 34 meters. Okay, so that was more or less the same that we did at the beginning, but let's assume you have different districts in your city and you want to detect the highest and lowest building in each district. How would that look like? Interesting question, right? I'm going to show that to you in the next minute. So these are my districts here that you see on the top pane, these yellow areas. So I have 3 different districts, and I want to have for each district the maximum and the minimum, so the highest building and the lowest building. So what I do here, what's very important is that you have this structure of child and parent processes. And I'm telling here, let's go back to this first one, find highest image objects. So I'm telling here in this parent process, look at level 2 and image objects, and on the class district. So that's one level higher than level 1. Level 2 we have the districts, and level 1 we have the buildings. And in this parent process I say, all right, look at level 2, my districts. And in the process, in the child process, within this parent process, I'm telling eCognition, look at one level below, that's the building level, level 1, and check there within this district for the highest and the lowest building. And it's important now that in the child process you set the domain, let's check that one, so the scope to sub-objects. So it's looking at the sub-objects of the districts. The class filter is building, so it's looking at the buildings on level 1. The super objects is level 2, and there it's gonna look for the extrema type maximum of the DSM and classifies that as maximum class. So this structure allows you to set constraints in define the domain on a super level, and then it applies these child processes to each image object defined in the domain of the parent process. Okay, I'm gonna execute this one, and you should see that we have more than one green building, which are classified as maximum, and this parent process is doing the same as the one before. It's just simply classifying minimum buildings, and you already see that I see 3 green buildings, but yeah, using the image object table makes life easier. So you see here we have 3 minimum buildings, and you also see them highlighted in the top pane. And also bottom pane with also 3 maximum buildings, so for each district. And using this parent and child process structure allows you to actually go deeper into the capabilities of eCognition and create such interesting analysis approaches. All right, so that was it. eCognition Deconstructed. Deconstructing this find domain extrema algorithm. I hope you enjoyed it. See you next time.